Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nasuha binti Azmi with Matric number 1170834. So in this video, I'll be talking about the use of nuclear in agriculture and will later on explain about a recent research made regarding nuclear and agriculture. So let's get started. Okay, practically everyone is aware about the role of nuclear technology in the electricity generation and energy diversification, right? But little did we know that actually nuclear technology also has brought a significant improvement into the role of medicine and agriculture industry. In agriculture industry, the nuclear technology utilized will depend on the technique of isotope and radiation applied. So, among the uses of radioisotopes that can actually benefit the agriculture industry are, first, to construct a high-yielding crop seeds, which indirectly can also increase the final production of the crop. Second, is to find out the role of different fertilizers that can actually react on different type of plants. Lastly, is to kill the pesticides that can actually cause harm on the food grain, and this can be performed using certain isotope. Okay, basically, radiation can be classified under two different categories, which are the ionizing radiation and non-ionizing radiation. So first, ionizing radiation. Ionizing radiation has a wavelength less than 100 nanometer, and these actually are the high charge energy particle, such as the high energy photons and high energy electrons. So here in ionizing radiation, gamma rays and X-rays are among the important ionizing radiation. Next is the non-ionizing radiation. So non-ionizing radiations are the radiation with wavelength more than 100 nanometer, and it is further divided into electromagnetic fields and optical radiation. So basically these non-ionizing radiations are not commercially applicable for the productivity of agriculture. And do you know, one interesting fact is that the Food and Agriculture Organization (FAO), along with the International Atomic Energy Agency (IAEA), works to support and facilitate the development and adoption of this nuclear technology either at national or international level to enhance and improve more on the agricultural productivity. Okay, now let's take a look into the four applications of nuclear in agriculture, which are the plant nutrition studies, control of the insect pests, harvest refinement, and also the food preparation and preservation. Into the first application, which is the plant nutrition study. Okay, for the plant nutrition study, it examines the efficiency of fertilizers into the plant. So, as we all know, it is very important that a maximum amount of fertilizers during cultivation finds its way into the plants, and it is also important that only a minimum amount of fertilizers were lost. So here, radioisotopes are very useful in estimating the amount of phosphorus and nitrogen available in the soil, where this estimation will help to determine on how much of phosphorus and nitrogen fertilizers should be applied to the soil. Thus, fertilizers that are labeled with radioactive isotope, such as phosphorus 32 and nitrogen 15, have been used to study the uptake, retention, and utilization of the fertilizers. Second, insect pest management. As we all know, insect pests are indeed a serious threat to the agricultural productivity. They do not only reduce the crop yields but also transmit disease to the cultivated crops. So, radio-labeled pesticides were used to monitor the persistence of their residues in the food items, soil, groundwater, and also environment. And not just that, this study also have helped to trace and minimize the side effects of pesticides and insecticides. Next, for the harvest refinement. So, plant breeding requires a genetic variation of a useful traits for the crop improvement. So here, different type of radiations can be used to induce the mutation to develop the desired mutant line. For example, the ones that are resistant to disease, that are of higher quality, that can allow early ripening, and most importantly, that can produce higher yield. The crop varieties developed by the induced mutations have been found very useful and valuable by many national authorities, so they have been released and approved for the commercial production. For example, most of the groundnut and black gram grown in India are from the mutant varieties that are developed at the Baba Atomic Research Center (BARC). And there are also many similar successful mutants that are in use in other countries. For example, is the high-yielding mutant barleys, which can utilize a higher dose of fertilizers for an increased grain production. Lastly is for the food processing and preservation. Okay, as we all know, the demand for an instant food which is wholesome and has long shelf life is growing. Thus, the loss of the food can actually be avoided by employing an efficient food preservation methods. So here in this method, radiation can be used to destroy the microbes in the food and to control the insect and parasite infestation in the harvested food, and also to prevent further various kinds of food spoilage and food wastage. The extension of shelf life of a certain food for a few days by irradiation is enough to save them from spoiling, because irradiation of foods can actually produce a safer food that has a longer shelf life. Thus, certain seeds and canned foods can be stored for a longer period by gently exposing them to the radiations. Okay, now I will share about a recent news regarding nuclear and agriculture. Okay, this study was done in 2019 by several people under the University of Urbana-Champaign at the USA. And from this study, this group of people suggested that the waste heat produced from the nuclear power plant to be utilized for the agricultural use. Okay, as we know, nuclear power plants are among the most safest and most reliable sources of power. And actually, these nuclear power plants also produce a staggering amounts of thermal energy as their byproduct. Nuclear power plants constantly generate power at all times of day at whatever site they are chosen to be built at and under almost any of the weather conditions. So, as a result, a huge amount of waste heat are generated from the nuclear power plants. All thermal power plants reject the waste heat in the process of converting the thermal energy to electric power. Nuclear power plants are the largest waste heat producers per unit of all the power sources due to the combination of their large power rating and their largest operational capacity factor. So, traditionally, this has been a weakness for the nuclear power plants as it increases the risk of damaging thermal pollution and also has even led to costly plant shutdowns. So, if the nuclear power plants can utilize the waste heat produced before it is released to the environment, the weakness of this nuclear power plant earlier can be transformed from weakness to an advantage of the industry. This is because by then the nuclear power plants will have an additional secondary source of revenue. Then the environmental regulations also will be easier to satisfy. And lastly, the virtually untapped source of energy can be utilized by the non-energy industry such as agriculture. However, when discussing about the use of waste heat from the nuclear power plant, especially for the agriculture, it is understandable that there must be a concern regarding the contamination with the radioactive byproducts from the nuclear power plants, right? The use of the term waste in discussion of these nuclear power plants can be perceived as ominous. But to be clear, the waste heat from the producing power via the ranking cycle is actually unrelated to the controversial nuclear waste that is usually being regarded as a byproduct from the nuclear fission. The waste heat stream from the power plant condenser is actually isolated from the reactor core that will be the source of the potential contamination. And actually, waste heat is strictly regulated to prevent the radioactive contamination of the surrounding area. And actually, the only radioactive contaminant that is consistently released from the nuclear power plants in measurable quantities is the tritium, which is an isotope of hydrogen in water molecule. The tritium loads in the waste heat water are monitored and maintained below the regulatory limits and are well below the level that may be considered dangerous. So, that is regarding the waste heat from the nuclear power plants. Now, in terms of heat required for the agriculture, the heating needs actually largely depends on the climate and also depends on the crops types. The heating need is actually strongly influenced by the temperature characteristic of a geographic location. And this temperature of geographic location also will actually ultimately determine the choice of crops type and the heating application needed for that particular location. The climates with colder temperature, in particular a nighttime temperature, will require more heat. However, this will also depend on the crop specific heat demands, and thus for US generally only a low grade heat is required for the agricultural operations. However, when using the waste heat in general, there is a concern that a significant amount of heat may be lost during its road to its application. So hereby, to use the waste heat effectively and inexpensively, the application should therefore be located as close as possible to the source of the waste heat. Furthermore, it was proved that a variety of horticulture products have been produced with the waste heat supply production system, and there exists a limited but instructive cases of commercially successful horticulture production system employing this waste heat from the nuclear power plants. For example, the waste heat from the Grenoble Nuclear Center nuclear power plant in the France has been used in the greenhouse tomato and cucumber protection with a comparable yields compared to the non-waste heat greenhouse production system in the region. And in addition, the reuse of the waste heat from the nuclear power plant for the food crop production has actually offered an opportunity to realize the synergy at the intersection of food and energy in the food energy water nexus at the densely populated region near the nuclear power plants in the US, such as the Chicago metropolitan region. So, in conclusion, with all the highlighted reasonings and references, it was believed that the waste heat from the nuclear power plant actually has the potential to be an alternative heating sources for the fossil fuels in the agricultural systems. And not just that, this implementation also actually can benefit both the nuclear power plants and also the agriculture industry. So, that is all for this video. Thank you.